We're building a messaging system that's used by all other marketplaces. I've worked on this since I joined Shipstead almost 8 months ago, and it's being rolled out. And it was a bit of a bumpy ride, I'm going to be honest with you. Basically, the messaging system has two main components. One is the backend, which is built on Java with Spring Boot and uses Cassandra as a data store. And it runs completely on the AWS. We're a cloud-only company. And then we have three front ends, which is an Android SDK, an iOS SDK, and a JavaScript widget. I work in JavaScript. I'm a JavaScript engineer, and I'm going to go through the process of building a JavaScript front end, a plug-and-play widget, which basically what we want is you create a div, you instantiate the object, you specify the ID of the div, and then you get a widget that's responsive and works with real time, and it's customizable. And anyway, it has everything you would expect from a messaging platform, a modern messaging platform. And basically, what was the path there? When I joined, I was told, so I had the onboarding, and they said, so basically you need to build this widget, and they left. So it's like, okay. First, where do you start? You try to know your customer. It's like, okay, who will use this widget? Why? What do their needs are? And for me, the first question was, who is my customer? Because it's not that easy. Initially, you say you have the users. The users are always your customers, are the final customers. They use the product. They create the revenue. And for the widget that I was building, my users live in different geographies, from Eastern Europe to Asia to Latin America. They use exotic browsers. For example, we have users in Belarus which use Yandex, the Yandex browsers. Almost 20% of the traffic is on the Yandex browser, which if you live here in Barcelona, you may not have heard of it, or not even install it. They have different connection speeds, which is very important. And also they have different expectations based on how the web looks in their geography. They expect more or less features. For example, sometimes if the connection internet allows it, they want real time. Sometimes they're happy with slower response time. We also have professional users. Imagine the real estate agent on Fotocasa. They want to use email. They don't want to have a chat like WhatsApp. They want to be able to email multiple users at once. Then you have the private user that sells something on Vibo. They want a WhatsApp experience. So these were my customers, and it was like a long and diverse list. But then I also have another set of customers, which are the marketplaces. In order for me to reach the users, I need the marketplaces to buy in, to install the widget on their website. And there was a previous version of the widget, and we've learned some things from that. That was very 90s looking, developed with jQuery, and didn't work half of the time, and didn't even have pagination. So if you had like 51, we display 50 conversation. If you had 51, bad luck. You had to delete one to actually see them all. So what we've learned, the marketplaces are customers that are built on different technologies, ranging from React or Angular, like really new web technologies, to Smarty and PHP, which I didn't think was any site left using Smarty and PHP. Apparently there are. They want to be able to customize the widget. So they want, okay, we have our own branding, we want to have our own look and feel, and we want to put that on the widget, but we don't want to break the widget in the process. We want the widget to work, but the way we want it to work, which is a bit, Then they have different build systems, or none. Some use Browserify, some use Webpack, some use nothing. They just FTP something, everything in place. Some have dedicated front-end teams. So they have front-end engineers with a lot of experience in JavaScript. Some, they're like really small marketplaces that only have like 3 or 4 engineers, which are jack of all trades, and they need to have something that just works for them, like drag and just create a script tag, import it, and it works. And sometimes they have hard to predict release cycles, which created a lot of problems for us, because they don't always update to the latest versions. Sometimes they don't update in general. They say, yeah, we're going to update, but they don't. It's like, we have something else to do more important now, which I'm not denying that, but for us, this creates a lot of problems, because we ended up maintaining multiple versions of the widget, and also we ended up maintaining multiple versions of the API, because we had an older version of the widget, which used an older version of the API. Not everybody updated. We had to keep the old API going. And at some point, we had 3 concurrent versions of the API. So it was like, this is not scaling. I mean, the costs were going up because you needed servers, and there was very little return on investment. And the problem was that they didn't want to update. So putting that together, I had my first set of requirements when I joined. This was like maybe 3 months in my, oh no, actually 3 weeks, sorry, 3 weeks in my job at Shipstead. And they wanted a widget that's cross-platform and responsive, customizable look and feel, supports browser that I didn't know exists, like the Yandex browser here. It's basically built on Chrome, so it's not that weird, hopefully. They want to do that without breaking customization or responsiveness, support React, support direct injection via the script tag, and everything in between. So it needs to work. I don't know what technology they have, but it needs to work with them. They need to be able to plug it in and work. Then I had a request from my own product team, which was like, we need to be able to update the widgets to newer versions without the marketplace. So even if they don't want to update, we should be able to push the new version to them. And they should not be able to reject it. We should do this automatically, which again was a very political decision, and was like a lot of back and forth. And then also you have the UX team, and the product is like, oh, we need real time. We need a lot of cool features. And this is the first set of requirements. But of course, there was more. That would have been easy. When I started the project, we had deprecated APIs that were about to be removed, not yet removed. The new ones were being developed. So I needed to develop supporting an API that didn't yet exist. So a bit of a chicken and the egg problem. Then the server at the time didn't support real time, but they wanted to have the real time experience. So I needed to poll the server. But polling the server every few seconds would create a DDoS attack. We would just attack our own server. We would float it with requests. So then I solved the problem by only polling for the active tab. So if the user moves away to a different tab, I stop polling, and I only start when the tab becomes active. And then another one from my beloved product team is like, we want to run A/B tests. And if the marketplaces don't update to a new version of the widget, which is, they're not going to release 2 simultaneous versions, like the 2 versions of the A/B test. So we need to be able to do that independent of them. We need to be able to bypass and stuff to our users without any input from the marketplace, which is really difficult because they own everything. So they own the site. We just give them a JavaScript that they need to execute in their site. So anyway, dream requirements. This was it. This was my first time. It's like I'm going home, and But then it was like, okay, how to address this? How to actually do it? Because I have a rent to pay, and I need. So first, I started by dividing the problems into smaller problems, not necessarily easier problems, just smaller, more like less scary problems. And first was abstracting the API. I wanted to abstract to separate the widget, the UI, from the API assets. Then I needed to develop the widget, handle the customization, and handle the updates and A/B tests. And I kind of did that. which I'm very proud of. So first, starting with abstracting the API, I didn't find an Ajax image, so dishwasher will do. Basically, the first thing I did was create a component called the connector. This was a separate, from the widget standpoint, this was a third-party library, even if it was developed by the same team, me. And this would abstract all the access to the API, and I would npm install it in the main widget. Basically, what we would do in the, for example, let's say I receive a counter update event from the API. At some point, I would have to do polling. So every now and then, every 30 seconds, I would do a get to a specific URL. When the promise would fulfill, I would emit a counter update event. Then when I would have the new API and I could open a socket, I would receive that data via the socket. But all these functionality, the first one, which was on the old API, or the new one on the newer API, these were all wrapped in the connector. The widget, the UI part, was unaware of how the data was being received. So in the widget part, I would just do connector on counter update. And this part was agnostic on how the data was received. The connector, even on the Ajax, would handle the ticks internally, would know how many times per minute to poll, and so on. And the same happened from normal API calls. So for example, if I wanted to get the conversation, I would have a syntax like this: connector, use case, get conversation, execute, and I would pass the conversation ID, the unique key of the ID of the conversation that I wanted. This would return a promise that would resolve to an object, to an entity, to a smart object that had, like a proper object that had methods, that had attributes. And for example, if I wanted to mark the conversation as read, I would just call this method. And then in the other side, in the connector, I had the old ugly API and the newer, more RESTful API. But from this was agnostic of what happened. For example, if I would mark the conversation as read by doing a post or a put or something, from the widget's perspective, this was not transparent. The widget didn't care how the connector would do his job. It would just tell the connector, mark this conversation as read. Whatever API the connector would use or whatever HTTP method, that was the connector's responsibility alone. And for the connector, it's a library, so I only have unit tests for it. It basically has an 85% code coverage, which is pretty good. I mean, not 100%, but I don't think anybody actually has 100% in the long run. But this gives me a good, gives us like a good quality, a good level of quality. 85% code coverage is good. And how do I test it? I only do, as I said, unit tests with Karma. I use chai for assertions and sign-on to mock JSON responses. Imagine, so this always connects to the server. So I need to mock a response. I need to make sure that if I receive a certain JSON, that's parsed correctly and everything is handled. So I need to mock that, and I use sign-on for it. And all the tests run on Phantom.js. I don't do any cross-browser testing at this level. This runs on the simplest headless browser. But given that Phantom.js is being discontinued, I will have to migrate this to Chrome. And to release, how to release this library. So this, so far, is a library. All the code is stored in GitHub. And whenever I wanted to have an automated release process, so every time I tag, this will run a tagged build on Travis. If the build passes all the tests, it publishes an NPM package to our local NPM registry. We have an internal NPM registry in Artifactory. Any questions until this point? Yes, please.
When you have a lot of tags, how do you manage when you have been 1 year developing this, you have like 100 tags, or you don't do as many releases?
We don't do that many releases in the connector. And also is this, so the tag, it's always the version number, which matches the version number in NPM. So I can just, in the NPM, in the package.json of the widget, I can say I want this version. And then run npm install and will bring me the correct version. So it acts like any npm registry, just it's hosted internally. Any other questions? Okay, moving forward. The widget. This was the main part. This was probably the least interesting to develop, but also because it's just a Vue application, but also the most visually important, because this is what the user sees. This is what the project manager sees, and this is actually the UI. And to do that, I used Vue. Are you familiar with Vue? Anybody? It's basically a lightweight version of React. It has features from both React and Angular. It's, for me, I prefer it over React. It also implements virtual DOM. It has a component called vuex, which is a state store. In a similar way, you have Redux for React. We have vuex for Vue. I also use a Vue router to manage the routes. For example, conversations need to be stateful. So if I'm talking to a person and I copy-paste the URL to a different browser, I want that conversation with that specific person, not the inbox of the widget. So I needed a router for that. And I also needed to use the DOM API, which was a bit of a trade-off. It was not my happiest choice. Basically, the architecture of the widget. If you remember, I have a header, messages list. Each of the messages list has multiple messages list items. The same with the conversations list and a chat input. And also a conversation menu, which allows users to delete or block that conversation. These are Vue components, which means they're self-contained, and they're used like this in an XML style language. By the way, I'm asking again, who here is familiar with Vue? Do you want to go into more details on how Vue works, or? Oh, I'm going to go no. Okay, so basically, applications have a state, which is like which is a data representation of what's being displayed in the application, what's going on. So in modern applications, I have a state store, and then components linked to that state store, and they change whenever the state changes. So for example, when I select a conversation, I mark the new conversation as selected in the state. And then that specific conversation list item with that conversation will mark itself as active. The chat header will display information for that conversation, and so on. And most of the components get their information from this state, which is kind of like the default behavior, except the conversation menu, which needs to be injected from the parent. I need to inject, because I have a list of multiple conversations, and each conversation has its own menu, and it's linked to that conversation. It's not linked to the store. And everything that ends with item is also a child of a container, which means it will have the state or information that needs to display injected from the container, from the parent. So for example, if I have the list of conversations, this works on infinite scrolling. So I scroll, the container detects when has reached bottom and loads a new set of conversations and creates conversation list item elements for it, like here. This is the actual code, a bit trimmed, but it's the conversation list item is a unordered list, and then it has multiple elements like this. And how was that developed? With Babel. So I use ES6, and we build it with Webpack, NPM, and we're looking to migrate away from NPM into Yarn. Yarn is supposed to offer better performance. It also has a log file, so you don't have that, have you tried removing the node modules? Anyway, this is pretty standard boilerplate Vue application. If you use the Vue CLI, this is kind of like what they're going to create for you. But at some point, I had to use the DOM API directly, and this practice is not recommended by Vue because you can have conflicts. If you had Vue already handles events or creates elements in the DOM itself, and if you do that outside the Vue engine, it may confuse it. You may add handlers, event handlers that then you don't remove, or you may create elements that the Vue engine is not aware of, and they're not going to remove them. But unfortunately, I didn't have a choice. Because this is, for example, one of the things that I had to endure during the development. So I have this contextual menu, which allows the user to either block the current conversation or delete it, which is needs to act pretty much like as a standard contextual menu. You open it, and then if you click anywhere else on the page, it needs to close. And most people will say, well, you just add an event listener on the body, and whenever it's clicked, you close the menu, which works, but not in Safari. And not on the iPhone, which iPhone users are very valuable because they use it a lot. They're power users, So not cutting them out was like, no, you can't do that. You need to. So then I did some research on the internet, Google search. So I found Quirks Mode. Are you familiar with Quirks Mode? It's a site ran by a Dutch guy, which is like probably the best resource for JavaScript quirks and weird bugs. I think he needs a girlfriend or something, but I'm happy if he doesn't get one because he does this. And it's like these are the things that will, if I do any of these, it will work. So first is the target element is a link or a form field. Obviously, I need the user to be allowed to click anywhere. This couldn't work. The target element of any of his ancestors up to, but not including the body. So imagine, I don't know the structure of the HTML outside the widget. They may have one parent, multiple parents, I don't know. The only thing that I was sure that was there was the body, but that doesn't work. Has to have an explicit event handler for any type of mouse events. This can be an empty function. So if you actually put an empty function on any of the parents, it will work. Or you need to put a cursor pointer on everything, which again was not, the UX guy didn't know. So it's like, okay, what do I do? So I created an overlay. So whenever you open the menu, it creates a big overlay on top of everything. And when you click anywhere, you actually click on the overlay and closes the menu. And because the overlay I wanted on top of everything, I needed to put it exactly before the closing body tag. So outside the scope of my widget. To do this, I couldn't do it with what Vue provided. The Vue framework only allowed me to change the HTML here, not outside. So back to the basics. I didn't have jQuery or anything else. So just old school it a bit. Remind me of the early 2000s. And at some point, I did this with the overlay, and it worked. And now iPhone users can close their menu without refreshing the page, which made the UX guy really happy. I also had another problem because I don't know if the site, the widget needs to be responsive. So I don't know what they have in the head, if they have the correct meta tags to ensure that responsiveness and media queries in the CSS work as expected. So what I did, whenever the widget was created, I would inject these meta tags in the header, and every time it was destroyed, I would remove them. So in order to inject these in the header, I also needed to fall back to the DOM API. And this is a feature flag. So it's by default turned on, but if they use their own, they inject their own meta tags, they can turn it off in the configuration. And that's about it. Do you have any questions on this part? Yes?
Couldn't you have, like, went up in the DOM tree up to body and get the...
Yeah, the problem with that is that I don't know. He may have a section like this, so it can have multiple things in the body. He didn't necessarily have one child in the body. The body could have I don't know what they have because...
From your element, couldn't you have just gone up?
Yeah, but then if they have a header, that's outside of the parent. So I'd have messaging, content, body directly.
Okay.
And if they click on the header, nothing would happen. So I did that. Don't worry, I did that. That was the first thing I did. And then was like, we're gonna get all the children in the body and add empty for them. And I was like, dude, just put an overlay, it's cleaner, you know. And anyway, any other questions on this? Yes, please.
The connector was like deployed in the server side?
I'm sorry?
The connector
No. It's injected in this application. It's like so I have the widget, which is the Vuejs application, which is the UI, what you see. And then in order to ensure that communicates correctly with the server, I use the connector, which is a component that I bring in. Any other questions? OK, moving forward, customizations. These are, some of the sites are really big, and they invested a lot of money in their branding and their logos and their colors. And they don't want me to slap them with something that doesn't match. Because, you know. So I needed to allow them to customize it. Basically, we only allow CSS customizations. But imagine this. We want to allow them to customize while not allowing them to break it, or not to break it too bad. You know. So what we did, we adopted BEM, which is a block element modifier. This is a way of namespacing CSS classes. So each element has a specific CSS class, which is also relative to its parent, and doesn't use cascade. So it kind of removes the cascading from cascading style sheets, but solves other problems in between. So it's a bit of controversial way of doing things. But at some point, so if you look here, I would have the message header. And then in the message header, I would have message header _meta, _thumb, and so on. This is the BEM syntax. Classes need to be like this. We have a very opinionated Italian designer who's like, this is BEM. He's OK. I do this to him. It's not offensive. So anyway, and because this doesn't leverage that much on cascading style sheets, on the cascading part of cascading style sheets, we use Sass with mixins to create to assemble the classes. So I would only declare a set of properties once. Let's say colors. I want the header and the footer to have the same color. So I would declare the color as a Sass mixin, and then I would import it in the header class and in the footer class. Are you familiar with Sass? It's less that doesn't suck. So anyway, moving forward, the way we organize the Sass and the CSS was in two main categories. One, we call it the layout. The layout positions the elements and ensure that elements are always in their place, they have the correct width and height, they act responsively when the user goes on a mobile phone or resizes the window. And then we have the theme. This would handle the colors, the border radii, because some want like rounded borders, some want square borders. And also we inject the icons as data URLs. So we have icons, like for example, a small photo if you want to attach an image, or a paperclip if you want to attach a document, or this kind of icons, we inject them in the CSS as data URLs. And these should be overridden by marketplaces. Basically, and we serve everything. We serve a default theme, and we serve the layout completely in one CSS, and then they can override the theme. Yes, please.
Why you use data URLs to avoid calls to sprites? Why do you use data URLs? You wanted to avoid calls to your servers?
Because we wanted to. The problem is this needs to be on under our control. Because if you remember, we want to update them without them knowing. So everything needed to be loaded from our server or from S3. We use S3. So we wanted to have the minimum numbers of requests to S3. Or we don't want to give them like, put this CSS in that folder, no. It's like, you just inject this script and it does everything along, everything it needs. And then it was easier if we just ship a CSS with everything. And we ship only 2 files, one JS and one CSS. Any other questions? And why don't we allow them to customize the layout? For example, our UX team did some research, and for example, this is on mobile. When the keyboard goes up, we hide certain elements. We do vertical media queries, because otherwise, if this tile was here, you couldn't see any of the messages. So we do a lot of these things under the hood to make sure that the user can use it without problems. It's still user-friendly. So if they start messing with the layout, all of these goes away. So we're trying to strongly discourage. We can't forbid them because we wouldn't be good colleagues, but we strongly discourage by just shipping a minified CSS and don't touch it. So the last part, update automatically to marketplaces and A/B tests. And for this, we developed something called FAST, which is front-end as a service technology. Not our brightest moment when it came to this name. But we're much better at programming than we are at naming our components. So basically, what does FAST do? It's a delivery system. Basically, they don't get access to the widget. They just get a small snippet of CSS that connects to a server, gets the actual code for the widget, injects it in the page, and runs it. So how it happens is, let's say user X goes to the messaging center. And then this site will have a small snippet of JavaScript called the FAST client. The FAST client will connect to its server and will ask, for site X, this is Le Bon Coin, or this is Fotocasa, this is InfoJobs. What versions of the widget should this site have? The server responds with a JSON that contains information, and then creates script and link tags in the page that hit S3 and get the actual payload, get the actual widget. So they don't even get the widget to install locally. Everything happens via the internet, controlled by us. And as you can see here, the syntax is I inject the FAST client, which is a minified file, and then I request a component. This is meant for multiple components. Now we only use it for messaging, and I say I want the messaging widget for the environment production or pre-production. The site name is I'm Fotocasa, I'm InfoJobs, and then I can send an object with additional configuration. And that's it. That's everything they can do at their end. They don't have control over anything else. And then when the promise fulfills, which means all the scripts have been loaded, they can instantiate create the actual widget. And if at some point they want to remove everything that we injected in the page, which is really useful for single-page applications, so React, where you don't refresh, you need to remove it from the DOM. The promise fulfills to a function, which, if called, removes everything from the DOM. And if there's an error, no widget, no nothing. So, So how it works? For example, as I said, the fast client calls the server and gets a response like this. This is an actual response. You said the environment is pre-production. The resource name is messaging widget. And then I want the following scripts from the CDN. We use CloudFront. Are you familiar with AWS, CDN, S3? And I just say I want this script and this style, and I'm at that version. And that's the response. And so far, do you have questions about this approach? Everybody understood perfectly. All right, great. So Fast has three main components. Has first what we call the Fast API, which is built in Java, uses DynamoDB as a data store, and runs on EC2. So as I said, everything we do in the cloud. Then we have a set of CLI tools that allows us to manage easily the versions, which site is assigned to which version, and so on, or to publish a new version to the API. These are written in Python. And then we have the Fast client, which is very vanilla JS. So to do the AJAX request, I manually create an XML HTTP request. I don't know if you've seen this in the last 10 years. It has 140 lines of code, including comments, which I'm really proud of. I had like this, like, we tried to sell this approach to the marketplaces. They said, dude, we don't like because we don't control what happens in our site. And then it's going to be slow because you need to load the Fast client first, and then you need. So I had 1 kilo. It's like, OK, you have 1 kilo. This client needs to fit 1 kilo. Otherwise, we're not injecting it in our site. So 140 lines of code, minified and uglified, 1 kilo. It guarantees the orders of the script. So if you have multiple scripts here with dependencies, it injects them in that specific order in the DOM. Provides a cleanup mechanism. As I said, if you want to remove everything that was created by the last run, you call that function and it will remove it. And you also have CSS before, and you can specify a CSS selector, and the styles will be inserted before that element, and the same for scripts. And why is that useful? So for example, we have our CSS. If you remember, we serve the layout and the default theme in one minified file. And we need them to allow to override this file. So what we do, they create their own theme file where they override the colors and everything. This is loaded by the normal flow. So it's placed in the HTML. The browser parses the code. It loads the CSS. And then when we call Fast, we specify a CSS selector. And this will insert the default theme before that in the DOM. So we have the layout in the messaging.min.css. We have the layout and the default theme. And the default theme is going to be overridden by their theme. Questions?
But yes. Make sure that they will not override the file.
Yeah, I mean, I'm assuming that they're engineers, not monkeys, although not always the case. But anyway, most of the time, so there's no. At some point, we're colleagues. We work in the same company. We provide them with mechanism. And we guarantee that in this fashion, the widget will work and we will support it. If they start hacking and they don't follow the documentation, they're on their own. And they're going to quickly revert and come back. Because so we also if you don't want people to do something, just make it really hard to do it, because people are generally lazy. If it's hard, I'm not going to do it. And also don't document it, because at some point, if it's not in the documentation as you can do it, they're like, I'm not just going to. And there are, of course, some pros and cons with this approach. The main con is we have around 50 kilobytes of duplications because we always send the default theme to be overridden by them, which is around 10 to 15 kilobytes depending on the sizes of the icons.
You can maybe add an option to say, okay, I don't want to go.
No, because if they break it, we can guarantee to the final customer, to the widget, to the user, that the widget will work. So even if they break something really, well, not really bad, decently bad here, or they forget something, the default theme will come into place and display the things correctly. So you can still read it, it will still be accessible to you. So it's a set of pros and cons. And with this approach, it's fast, given the fact that we can inject things at their end without them knowing, we can also do A/B tests, because without them knowing that an A/B test takes place. This is a very controversial topic in the company, because they're like, dude, you're doing A/B tests without me knowing. I know I'm not, but it's just, okay, turn it off, guys. Yeah. Okay, so there was another problem with this approach. It was called React. A lot of our sites use React. And if you look back, everything here relied on, when I started building the widget, the first customers were the Smarty and PHP guys. So they were happy with this. The guys with React was like, dude, you can't do that. This doesn't work for us. This breaks everything. We have a router. We have a single page application. We have everything modern. So we're like, okay, we need to support React. So a third repository with a React component, which we publish on Artifactory as a NPM package. And this React component wraps around fast, which wraps around the widget. And everything is very asynchronous, which creates a lot of bugs that are very hard to reproduce. It's like it takes, like 20 times to reproduce a bug. And it's like, okay, because they report a bug, and you're like trying once, twice. It's like, dude, doesn't work. Send you a screenshot, because for the tester, it's always like the first try. And look at the screenshot. Okay, you're not crazy. I'm just going to keep trying. And at some point, it happens. And when it happens, I was already bored, and I wasn't looking on the logs, so I have to start again. So anyway, it was a bit of fighting a hide guy, like firefighting. Imagine you have a spoon with water, and you're trying to put out a forest fire, So anyway, in the end, we managed to pass this part, and we ended up, we need to test it and release it. So imagine this. You have Fast, which is a standalone project with an API. Around it, you had a React component that needed a React application to actually work and be tested. And then everything needed to load the widget somehow and be tested. So it was like this. So we had some major pain points. First of all, as I said, the entanglement, React Fast widget. This created a lot of edge cases and a lot of things that you can't really mock it. Because if we were to mock the Fast API and the widgets API, at some point, the whole work would be to just keep these APIs in sync or keep the mocks up to date. We also use Sauce Labs. Are you familiar with Sauce Labs? No. It's a device farm. So we run Nightwatch and Selenium tests, and we run them across multiple browsers. And Sauce Labs provides a browser farm, and you can say, you can configure in your Selenium client, I want to run this test on Windows 7, Chrome, whatever version. I want it to run on Mac, on Safari, so you can have a list of browsers, and Sauce Labs will just start VMs with those browsers, and you can run your tests in them, which is a third party that we're using. It's really good. I actually gave a presentation on it at the Barcelona.js. But the problem is sometimes the machines are slow to boot. So running the full set of tests could take an hour. And as a developer, I don't want an hour till I get any feedback from my test. I want feedback almost instantly. Like imagine this, you change 3 lines, do a commit, then for 1 hour you just Facebook, then okay, failed. Then imagine, after we tested, and we needed to test with a very high degree of certainty because we would automatically deploy to other sites. And if we break them, we will never deploy to them again. So we needed to, there's not a lot of room for mistakes. And then we also have a manual step that we put in where tickets need to receive business validation. Because, and you may be familiar with this scenario. You go into a meeting room, you stay there for 1 hour, you talk, then you leave, you talk the next day, and you realize that everybody understood something different, which is what happens. You know, like I was talking to some of my colleagues. That I'm not saying you're lying. I'm just saying I remember differently. You know, we need a manual step from business to validate that what I understood from the requirements is actually what they required in the requirements. And we also want to do 1 or 2 releases per week on normal flow. Normal flow means normal development, no panic mode. You know, in panic mode, we need. These were our main pain points. So what we did, we used Nightwatch. Are you familiar with Nightwatch? It's a JavaScript framework that allows you to write client-side tests. So basically, you have a browser object, and you say, go to this URL, make sure that this element exists, click on this button, make sure that this happens, and so on. You can write automated tests, like UI tests. And this is, as I said, Sauce Labs. This is the browser farm. So we would run this, like, go to that URL, click on that, make sure that happens, across, I think, 50-something browsers. Or browser combinations, OS and browser. So we run on Android, we run on iOS, we run on Linux, we run on Windows, we run on Mac. So what we did, we first split the tests into 2. We had a minimal set of tests. These will run against a small number of browsers and will only cover like core functionality. This was to give the developer some quick feedback. Like, if I broke something that, you know, like you can't send a message, that's something that people will notice, you know, or you can't access your inbox. And it also runs on mocked responses, which means I will always get some predefined responses from the API. And this also accounts for common mistakes. For example, what happens if you get a message that's like 3,000 characters, no spaces, or if the guy's name is, 20 letters or something. So we can mock for this kind of edge cases, and this acts is designed to run fast, around 10 minutes tops, and acts like an early warning system. So if I develop something and I run this set of tests, it should tell me, dude, you broke some like core functionality, you need to go back. Then we have the full set of tests. These, they run against all supported browsers, which sometimes takes more than an hour to do. They cover most of the functionality. We can't actually test for everything because then it's maintaining those tests will be another project on its own. But covers most of the functionality, and it covers the functionality that's painfully evident if it's missing, you know, like. And this runs on live APIs. So this actually runs the test. They deploy the widget to a React application, and then Nightwatch instructs the browser to go to that URL and do all the things that it needs to do. And to deliver, we had a choice: continuous delivery or triggered release. Of course, with this kind of, you can't do continuous delivery. And it didn't make even business sense. We need to inform the marketplaces that a new set of features have become available magically overnight, and we can't send them automatically like 3 bug reports per day, or like somebody updated the documentation. You know, that's a commit would generate a release. So we decided to have triggered release, which means a human operator decides to release. And to do that, because if you remember, we have to run multiple sets of tests, we have a manual step, and also we wanted to automate this because, well, I wanted to automate this because I don't want to do manual things. And we use Spinnaker, which is an open source delivery platform. It supports multiple clouds providers, so it supports AWS, the Amazon Web Services, supports the Google Cloud, supports Microsoft Azure. It acts like a pipeline. It doesn't do anything. It just starts different jobs at different times. So each job can return a status. I have failed or I have succeeded. And this can take decisions. If that job fails, move here. Or if it succeeded, move to the next step, and so on. And the jobs are handled by Travis, which is our integration server. We have a company account for Travis. And it's also used by Google, Netflix, Shipstead. And the reason we chose this over Jenkins is Shipstead is a core contributor of this open source project. We contribute to a lot of open source projects. We open source a lot of the things we do. And on this one, we invest a lot in this. So obviously, we're going to eat our own food, you know, as they say. Yeah, meatballs, Norwegian meatballs. So how the pipeline looks. In the normal flow, you have the developer. See, I have like that's me. Basically, the developer does some changes. The changes go to GitHub. The push to GitHub will trigger Travis build, which will run a minimal set of tests in Nightwatch. And this can happen multiple times per day. If this fails, I know that my commit was not good, and I can revert it or fix it, or pretend doesn't happen. And then when I want to release, as I said, we're using Spinnaker. And we start the release process in Spinnaker, which tags the master in GitHub. We have, okay, this is what we have at this time. That will start a Travis job, which will run a full set of tests with Nightwatch, but against mocks. And this will only run against the widget components. So Fast and the React wrapper are left outside. This will only test the widget and the connector, but with full set of tests. If this passes, then the code for the widget and the default theme, they get minified and they get uploaded to S3. Then we instruct Fast, a new version exists. Then we deploy that to our pre-production, which is a React application with Fast and everything in it. And there we run a full set of tests with live API. So this is as close to production as possible. And if this passes, it's like, OK, now it works. Let's see if it works in the way that product actually wanted it to work. So this here, the pipeline has a manual step, which is a business validation, in which we generally have a half-an-hour meeting where everybody who added a ticket or made a request is like, does it match? OK, move on. If it passes business validation, we upload everybody's pre-production environment. But we don't ask them. We upload them. We update them. And then, if nobody complains, because this is it. We just, like, you can't really break their production. But we're happy to break their pre-production. We're happy. They're not. But, they're in a different office. We will update their pre-production. Which is visible. If you break their pre-production, they're going to come and complain. You broke our pre-production again. If that doesn't happen, we're like, OK, in 2 weeks, we push it to production, which allows us to keep everything kind of like evergreen. We don't need to end up with like 3 versions of the API, one built like 6 years ago. So anyway, this is pretty much, this was the journey that I did in the last 8 months. This pipeline is still work in progress. We're up to here as of today. We moved, this morning was here, and now we actually integrated here. We actually do the fast thing automatically, because to upload, to tell the fast API that a new version was created, we have some CLI tools written in Python, and we needed to create a pip package, put it in Artifactory, and then install it into the Travis container. So anyway, cool, if you liked it.